All right, good morning. Move that a little so I can see. Use some of that, some of this. Okay. So, good morning, everyone. Hope we all had a good holiday weekend. I say good morning, everyone, as I'm talking to myself, since no one's here yet. But that's okay. I know a lot of y'all are catching the replays, or at least I hope. I haven't checked my YouTube count this morning. But per usual, if you are catching this live, kind of an ironic statement to make at the moment, but you can always catch the replays on YouTube. With all the normal YouTube accessories of fast forwarding, rewinding, skipping around, replaying, etc., etc. So we covered chapter 0 last time. We covered just some very, very basic kind of introductory stuff about Excel, how to type things, how to use formulas. We said you always have to use equals whenever you want to start a formula, and a bunch of other things as well. We talked about cell references. We talked about how to use the fill handle. We talked about the different ways your mouse cursor can look when you're on certain spots of an active cell or a non-active cell, all that good stuff. So we did complete chapter 0, and we had a couple of due dates. There was a syllabus quiz posted in Canvas, and I said no later than that. I had it in, I want to say, within 30 minutes of class ending. That's due by midnight tonight. Today is the 26th. Make sure you're always reading ahead. So today we're covering 1.1, 1.2, maybe some of 1.3. We'll have to see how far we get. Since we're in a new format, things are kind of different in terms of timing. But always make sure you're reading at least the next section ahead. I always reserve the right to give a pop quiz based on reading materials and not just the textbook, but I also have those chapter notes to share, which I needed to pull up, and I'll need to do that in just a second. A quick reminder on how to save stuff. I just left that in from the notes last time. Also, you are supposed to submit the chapter 0 spreadsheets in Canvas. I'm actually trying to remember if I set that up in Canvas or not. I think I did, but if not, I will double check this. Well, either way, I will double check the second that this class quote ends. And if it's not up there, then it will be up there by 10:45 a.m. So that's due by Thursday, midnight. Remember, that's our typical deadlines for things, midnight of the day that it's due. And then I said, anytime you're doing things, practice, 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 practice. If you're working on my math homework problem and you don't get it, even if you get it right, do it again. Hit the view similar example button. So that way you can practice it more, because there may only be one problem of a certain type in there, and just doing something once doesn't guarantee that you understand it. So know when you need to repeat something. With Excel, you're going to do things wrong 10,000 times. For every time you do something wrong, you're going to do something right. I can't tell you how many times I've done something wrong in Excel. So you learn by making mistakes. Failure is the first step to success, as some people would say, or some variation of that statement. Okay, so let me pull up one thing really quickly. That's not the one I want. Nope, not that. Where are they? There we go. So we're going to be using this file. So I said we are reading, you're supposed to read at least a section ahead, as well as in Canvas, you'll find these chapter notes to share, and I'm putting quotations up with my fingers. That just says the chapter notes that I wrote to share with the class, and these are usually just kind of brief. You might see some definitions, you might see some sentences, you might see order of operations. I mean, there's a million different things you could see, but you should at least look into the next section's worth. So in theory, all 8 or 9 or 10 of you will have read at least this bit for today. It'd be nice if you checked out the next section as well, but not the end of the world if you didn't. In addition, you should have read, here's our e-text, 1.1, so pages, I don't actually see, it says page 5 out of 44 for the chapter, so I don't know what page that actually is out of a textbook. But it doesn't matter because there's no physical textbook. But you should have read, I think this is in 1.2 already. Yeah, that's a short section. Nope, it's still there. Yep, there was just some PKA stuff in the middle of it. Usually it's at the beginning, but that one was at the middle. PKA being prior knowledge assessment. I don't remember what the A stands for. I was just looking at it too. Either way, you were supposed to have looked at all those, and you got some more PKA stuff. So you can skip to section 1.2, and there it is, 1.2. So you were supposed to have checked that up to page 22. And like I said, the PKA stuff is not necessary, but you may find that you need to work on that. So probably just make it quicker to do this. Sure is. All right, so as I mentioned last week, I use a mixture of sometimes we'll talk directly from the textbook, sometimes we'll talk directly from my notes, the chapter notes to share. I will often add to these notes. I might have a separate file where I do things in more detail where you're supposed to be writing them down. I may go back and forth between them. I'll pull up the the guided worksheets as well. We're going to be using lots and lots of stuff. So you're going to see me move around from document to document or file to file on the fly in class. And it might seem a little annoying to watch on just a single screen, and I can understand why that is. But this is exactly how I do it in the classroom. It's just I have a whiteboard in addition to the TV. So I have two pieces of media, if you will, whereas now I'm restricted to one. But the good thing is, like I said, on the replays, you got a pause button on YouTube. So if you need to take some extended notes, that's an option. Okay. Just gonna take my physical pages out for this to make things easier on me. So, 1.1, functions. Functions are something that we're going to talk about pretty commonly in this course, even though we're not actually going to reference them as functions. I'm usually not going to say, hey, this function, that function, this function, that function. We're just going to generally be talking about equations, but the equations that we deal with are functions. And functions have inputs and outputs. An input is the number or the thing that's going into it, and an output is a number or thing that's going out of it. So you have some old school notation that some people will use. They'll say, here's an input, and they put a little oval around it. They'll point an arrow at the word function, and they'll put a little box around it, and they'll put an arrow to the right of that, and they'll say output. So in other words, you take the input, you put it into the function processes it, and then whatever you get in the end is the output, in, out. One thing goes in, another thing comes out. If you put a 2 into the function, maybe it spits out a 5. But in order for something to be a function, every time you put that 2 in, you should get a 5. If I put another 2 in, I should get a 5. If I put another 2 in, I should get a 5. Functions are a process that are completely predictable with only one output for each input. So a function is a relationship where each input can only have one output. And I forgot to hit my enters first. Let's see if I can. Sometimes it lets me move things easily, sometimes it doesn't. All right, you know what? Forget that noise. I just have to remember to hit enter 5,000 times before I start anything. So let me just real quickly redraw that before we get too deep. Input goes into the function. And then after you process it, you get your output. Where, come on, technology, man, am I right? A function is a relationship where each input leads to only one unique output, i.e., which means in other words, if you keep putting the same input in, you should keep getting the same output, or it's not a function. So in other words, let's say that I want to put the numbers 3 and 5 into our function. So I put the 3 into the function. I'm just going to write f for function. And it processes it, and for some reason it spits out a 7. I'm not going to say why, but it spits out a 7. Maybe the function is x plus 4, so 3 plus 4 would be 7. And then you put a 5 into the function. And let's keep pretending that the function is just x plus 4. So take the number and add 4, so you'd get 9. And then I could put a -2 into the function. You better know how to handle your negatives and positives. And if you added 4 to that, you'd get 2. Now, what this sentence above is saying is if I keep putting the 3 in, so now let me put the 3 in again into the function, I should get a 7 again. If I put a 3 in again, I should get a 7 again. Every time I put a 3 in, I get a 7. So this right here, this collection of stuff would represent a function. However, let's say we have the 3, we put it into the function, and the first time it spits out a 7. And we put in the 5 to the function, and it spit out a 9. And then we put in the -2, and it spit out a +2. I'm getting a little sloppy with my arrows, but that's okay. They're still arrows. Now let's say we go to put the 3 in again, and maybe our function, maybe we were putting this into a calculator, and we spilled water all over our calculator, like you do. And now all of a sudden this thing's spitting out a 10. So the issue here is, the first time we put a 3 in, we got a 7, which means every time we put a 3 in, you should continue to get a 7 if this is a function. But then later, we put in the 3 and we got a 10. So because these are different outputs, from the same, that looks like same input, this is not a function. It's when you take the same thing, you plug it in, but you get a different answer. That just doesn't seem to make sense if you really think about it. Why would you plug 3 into something and get 7 one time and then 10 another time? Now, in terms of math, in terms of equations, yes, this is completely possible. But for functions, which are a special type of equation, this is not possible. You can never have functions that do the thing on the right side. And the way Excel works is Excel is basically one giant list of functions. So everything that we process in Excel has to be a function, which means if you keep putting the same number into it, you'll get a predictable output every single time and the same predictable output. Now, when you start talking about things like quadratics with this plus or minus square root property that you may or may not have heard of, again, that's not a function, but it is mathematical. It is an equation, and it's a wonderful series of equations. But again, we're not dealing with those types of things in here. We're dealing with functions 100% of the time in this course. So inputs are what go in, outputs are what go out. Come out, if you will. We have a constant function, which, by the way, on page 27, you'll see some of these definitions, hint, wink, nudge, page 27 of your guided worksheets right here. So maybe I'm, filling out some of these details. It's just a lot easier for me to type it on a word screen. If you don't remember last class, I mentioned that if I want to type on this, in order for me to scroll, I have to completely clear the screen. And sometimes I will type and write on this because it's not really any other good way to avoid it. But when I can, I will. So a constant function is a function or one in which the output is the exact same no matter what the input is. So if you want to use your words loosely, you could call a blender a constant function. You could call it a constant function. So I'm going to go loose blender talk. Let me switch back to my colors. So I'm just going to write in columns in and out. If you put an orange, a peeled orange, into a blender, hopefully, you could leave it peeled and have mixed results depending on how good your blender is. If you put an orange, let me actually spell it so the OJ kind of implies juice. If you put an orange into a blender, what do you get out of it? You get juice. Yes, specifically you get orange juice. That's why I said loose definition of the output. You can say orange juice or you can say juice. I want to just use the word juice for this constant function idea. So if I put an apple in, hopefully you have removed the core, and then what do you get out of it? You get juice. You can put a banana in. And what do you get? You get juice. So this would be a constant function. But I do want to note, you can be more specific. And it's not. So in other words, in out, if I put the orange in, what do you get out of it? You get orange juice. If I put the apple in, what do you get out of it? You get apple juice. If you put the banana in, what do you get? And I don't know why this just doesn't sound appealing to me, banana juice. So this is not constant. So when we're talking about real things, sometimes we can manipulate the data to be specifically how we want it to appear. That's what I've done here. I've manipulated data. You know what the news loves to do? Manipulate data. You know what researchers love to do? Manipulate data. We've got a little virus going around right now, and there's some research that say masks offer protection. There's also some research that say they don't offer as much protection as some people are saying. Now, which one's true? I'm certainly not going to say that. I am not the expert. But what I do is I read both sides and try to make an educated guess. And I say guess very, very seriously there, because that specifically, I mean, we're dealing with things that are smaller than, that are on like the femto and nano scale. And I don't know. But again, I'm not telling you not to wear a mask. I'm not telling you to wear a mask. I'm saying do some research, form your own opinions, and understand that there will always be people manipulating data. And we'll talk about that throughout this course. And I will never, ever, ever tell you which side is true. That is not the point of me as a quantitative reasoning teacher. My point of it as a teacher is to make you think, make your own logical conclusions, if you will, based on provided information. Something that we're never, ever going to talk about again in this class, honestly, a one-to-one function. This is a function, one in which every input and output is unique to each other. And I don't want to say it like that. I want to say every input has a unique output that is not repeated. So the idea of being a function is you couldn't put up here, you can't put the same number in twice and get different values. See, the left side was okay. We put in the threes 3 times, in fact, but because we kept getting 7, that's okay. That was a function. Here, it's not a function because we have the same inputs but different outputs. For something to be one-to-one, this has to be true on both sides. So if you see any repeated outputs, they have to come from the same input, but that's not true just to be a function. Look at this. You have repeated outputs that all come from unique inputs. So this example right here, and I'm going to use it with a different color, just kind of point at it. So note that this thing right here, this table, is not one-to-one. You can spell out the ones or you can write them as numbers. Kind of looks like an H almost, if you do it that way, for better or worse. So not all functions are one-to-one. But this one on the right is, because you don't even have any repeated inputs. You don't have any repeated outputs. But the right one is. There are no repeated outputs. There are no repeated inputs. That automatically makes it a function. That automatically makes it one-to-one. Now, again, this one-to-one idea is not something that we're going to see extensively throughout this course, but we give it as a definition. The domain is the list or set of all inputs, and the range is the list or set of all outputs. And again, some of these notes are already on that other file. Domain, list of inputs, range, list of outputs, inputs and outputs, numbers that go in, numbers that come out. Function, one-to-one. So again, all this stuff you've already seen in theory if you did your reading ahead like you're supposed to. And like I said, I will give you pop quizzes on this stuff occasionally, and they'll be simple as I can possibly make it. The only thing that I haven't mentioned previously that was on this list is independent and dependent variables. Independent variables are chosen values. Dependent values are calculated values. Independent variables are me, all right, I want to grab an orange. I want to grab an apple. I want to grab a banana. That's my choice. That's what I put into the function. So independent variables are what go in. So I'm just going to copy paste this to put it over here. And then make an additional note for each. Chosen values, these are your inputs. Whereas dependent values, they depend on some formula. They depend on some calculation. They depend on you turning the blender on, whatever it might be, whether we're talking pure math and numbers or blenders and fruit smoothies or juices. So dependent variables are calculated. These are your outputs. So domain relates to the independent, range relates to the dependent. It's kind of like in the real world. When you're independent, you don't depend on anyone. When you're dependent, you depend on someone. So dependent numbers depend on chosen inputs and a function that you put them into. Okay, so that's the basics of page 27 from our guided worksheets, as well as a couple of extra bits of information and a nice juice analogy for functions. Let's go into page 28, which is right here. Let me zoom in a little. And we have guided practice activity number 1. And I've mentioned before that we will not do every single guided practice activity. We will not do every single problem from guided I'm tongue-tied this morning. To be fair, not just this morning, every day. We won't do every guided practice activity. We won't do every problem from a guided activity just because we do it either. So I'll say which ones to skip and which ones not to do. I will not always do this for us. A lot of the times I might do some of them and say, all right, now when you go to Canvas, there will be an activity up there for us to complete. And I said that you don't have to do every single one, but I'm going to need a certain amount of participations by the end of the semester. So don't lackadaisically approach these and, you know, I'll do all of them the last 2 weeks. I'm not telling you how many I'm going to do each week or at all. I mean, it's random. So you need to do these as soon as possible. I'm generally going to do one a class, at least in the beginning, but sometimes it'll be one a week. I reserve the right to do 2 per class, to set up 2 to give you more opportunities. And like I said, you don't have to be correct. I would prefer that you are, of course. If you go in there and you see that someone's made a mistake and you know they're wrong, or you really think they're wrong, you could say, hey, I think that you may have done this incorrectly. Here's my work and here's what I've got. And then maybe someone else can come in there and confirm that, you know, student A or student B is correct. Sometimes I'll go in there and confirm that. But I'd really like to see a lot of input from the students. I know I'm talking a lot about how this class works in the beginning, but I feel it's necessary because there's so many different things. So with this activity, I'm going to do some of them for us, and then I'll leave the rest for you to do in a Canvas activity that I have not set up yet, but I will after class. It'll be available by 1:30 at the latest today, and I'll have all that written down later. So The annual cost of a car is a function of many inputs. List all of the inputs you can think of that determine the output of the annual car cost. They are not kidding right here that the annual cost of a car is a function of many inputs. I don't know why I used my mouse to do that. Many inputs. I'm just going to circle that word. So when you buy a car, oh, okay, this car costs $9,999. That's not the only cost of the car. The sticker price is definitely one of those costs. List all of the inputs you can think of that determine the output of the annual car cost. Now, I'm not saying don't determine the output. I'm not giving you enough information to do that. I'm saying list all of the inputs, list all of the different things like the sticker price. So I'm going to list maybe 3 or 4 things, and then I want another 3 to 4 as homework, again, in the Canvas. So I'll in Word, I'll type up exactly what all this will be. Text. Get a little text box. So the annual cost of a car is a function of many inputs. Now this says something specifically, the annual cost of a car. While you can say the sticker price, and sticker price is, when you go to the car dealer, what it says on the window. And I'm putting a question mark next to that one because it depends. It kind of depends on how you're doing this. Did you pay cash for the car? Because if you paid cash for the car, then your annual cost isn't really a product of the sticker price because you did that up front. Year 2, you don't have that payment. So that one's a question mark, but I would say that a better one is probably your car payment. Most of us generally don't own our cars outright unless they're clunkers. Now, I grew up driving clunkers and I own those outright. But once you grow up and need a nicer car that you don't want to break down and have the ability to afford a car payment or something like that, and that's usually what our average Joe does, or Jane. So car payment's probably the better one for a sticker price. So in fact, I don't even really want to have that. But if you are the person who buys the car for cash, and if it's your first year, then that's a good answer. So car payment, that was weird. So car payment's a good one. What else? What else could you think of? Well, when you drive your car around, eventually what happens? You run out of fuel. So you got to fill up at the tank. Now that is definitely happening every year, every month, every week, maybe with the virus, maybe you're not filling up as much right now. I know I'm not, but it is what it is. So fuel expenses. And I don't want to say gas because if you drive a diesel and you put gas in that, well, bad things happen. So fuel is a more proper word. Most of us have gas cars, but 1 or 2 of you, well, in a class of 10, I'm going to say maybe 1 of you owns a diesel. So fuel is another good one. What else? What else? What else? Oh man, I'm having a hard time coming up with these. No, not really. Well, what's that other big thing you have to pay every month? And if you're 18, 19, this is really expensive. Or if you've had a lot of tickets, this is really expensive. Your car insurance. You can't drive without car insurance unless you sign that DMV waiver and then they make you pay an exuberant amount of money. What is it, $500, $1,000? I don't even know anymore. And you might have to pay that every 6 months or every year. I've never been in that situation, so I don't know. So I'm not an expert. And I said I'd do 4, so let's see if we can think of one more. One more. One more. Well, shoot, my car always has problems, right? I mean, you got to put new tires on it. You could be even more specific than what I'm about to say. You could list some of these specifics. So new tires or new brakes, things like that. Or you could just be more general and say repairs. So there are many, many, many more different things that go into your car cost, how much you're spending on your vehicle every year that I have not said. These are the 4, maybe biggest one. I'd say 3 of these are the biggest of like the top 5. But there are a lot more. So I'm going to say in homework, in Canvas, answer 4 more. So again, I have not set up this Canvas exercise yet as of, what time is it right now? 9:01 a.m. But I will have it set up no later than 1:30 p.m. I will try and get it set up before my next class, but it is a race from trying to upload the YouTube videos and et cetera, et cetera, et cetera. Okay. Next up. So determine which of the following are functions. So some inputs and outputs, states and senators, and then senators and states. So what this first thing has done is it's swapped them. States to senators, so if you plug in states, can you say the senators as outputs? Or if you plug in senators, can you say the states as outputs? So one important thing to note for this particular problem is that there are, oops, that's fine. There are 2 senators per state. Now, this is not a poli-sci class, so I'm not going to ask you to list specifically what they are. That is not something I would ever ask you to memorize. But if you're curious, I imagine most of us live in Virginia. Our senators are Mark Warner and Tim Kaine, whether you like them or not. And I'm not expressing my political opinion there. I'm saying whether you like them or not. So those are our 2 senators. So remember, the idea of a function is, if you plug one thing in, you can only get one unique output. So if you plug one thing in, you can only get one unique output. So what this first question is asking us, if you plug in a specific state, can you have one specific answer? If so, then it's a function. If not, it's not a function. So let's say I plugged in, let me go to draw just to make this easier now. Let's say I plugged in Virginia. Virginia has 2 different senators. The outputs would be, again, Mark Warner or Tim Kaine. So I'm just going to write W and K. Your senators are W and K, Warner and Kaine. So if I plug in Virginia, one answer is Mark Warner and another answer is Tim Kaine. Well, that's a problem in terms of functions. So if I plug in a 3, I'm supposed to get 7, remember earlier, and then later I plugged in a 3 and I got a different answer, the 10. That was not a function because you have 1 input and 2 outputs. 1 input, 2 outputs. No, this is not a function. The output's not supposed to be the list of both senators, and this question is loosely written, so I can understand why a lot of people in group work tend to mess this one up, because, oh, okay, if you plug in Virginia, the answer is Warner and Kaine. Sorry, I got a cough, hold on. But we are talking about just one specific senator as an answer, so that's why that's a no. Now, however, the senators being the input and the state being an output, so I could say one time I can just say, all right, let me plug in Warner. And then you could say, well, what state is he from? He's from Virginia. Then a second time, I can go and plug in Kaine. And when I plug in Kate, you say, well, what state is he from? It's Virginia. So this is 2 inputs leading to the same output. That's perfectly fine. That is like, and this is going to look ugly for a second. Sorry for that. That's like right here when we plugged in an orange, an apple, and a banana and always got the same answer of juice. So one time we plugged in Mark Warner, he's our orange, and then Tim Kaine, he's our apple. I don't mean anything by that. I'm just being silly. And both time we got an answer of Virginia, which was our juice. So that's why the second one is a function. Those are drastically different approaches. So again, when the input's Virginia, because there are 2 possible answers, Warner and Kaine, it's not a function. You can only have 1 possible answer. But when we input a specific senator, oh, Warner, he's from Virginia. Oh, Kaine, he's from Virginia. And then go and list whatever other ones you want. Now this third one actually, states, then to the number of senators. So if you say a state, the answer is supposed to be the number of senators from that state. Well, I mentioned earlier there's 2 senators per state. So if I say Virginia, what's your answer? It's 2. If I were to put in another input, let's say North Carolina, what's your answer? It's 2. Let's say I put in New York, what's your answer? It's 2. And again, this is not asking for the names of the senators, it's asking for the number of senators. 2 is perfectly fine as an answer to be a function as long as it's the answer. As long as I'm not repeating inputs and getting a different output. So every time I plug in Virginia, I get 2, always. Every time I plug in North Carolina, I get one answer, which is 2, always. How about people plugging in a person and then the output is supposed to be anyone they've been married to? So if you used me as an example, if you said, Rodney Beckner, anyone they've been married to, this answer would be blank because I've never been married. If you said my friend Bob, and I'm using a fake friend, just making this up on the fly. Let's say Bob's been married to Jane his whole life, or at least since he's been an adult. Then when you plug in Bob, he would get Jane. But let's say you plugged in, I'm trying to think of, I'm not really good with celebrities and stuff. I had John Mayer, but I think he's just dated a bunch of people. I don't think he's actually married a bunch of people. So let's just go with a fake person. Let's go with Jim. And Jim was married to Jane for a year, and then he was married to Angela for 2 years, and then he was married to Betty Sue for 3 years. Sound like names out of the 50s. So if I plug in Jim, the answers would be, again, I think I had Jane, Angela, and Betty Sue, because Jim just had multiple marriages. That's one input leading to multiple outputs. So no, this is not a function. Because while yes, for some people, it's okay, there's only one output. Some people have been married 0 or 1 times. But there are a lot of people, some people think that half the population falls in this, but I would argue against that fact because it doesn't consider kids. But anyways, and it may not even be true with adults, and we'll get into that later in the semester. But again, because someone could have been married and then divorced, and then married and then divorced, and then married and then divorced, and then married and then divorced, that's not a function because there can be multiple outputs. Now, the next one words it a little differently. Instead of linking it to the individual people, it links it to a number. So now when I say Jim, his answer is 3 because he's had 3 spouses. But if I ask about Jim again, the answer is still 3. If I ask about Jim again, the answer is still 3. Whereas last time, the answer could have been Jane, or it could have been Angela, or it could have been Betty Sue. Or if you said Rodney, then the answer is 0. Or if you said, I made up another person, Bob, and he was only married to 1 person. So every time you plug each of these people in, they only have 1 answer. So yes, that is a function. The link between these two and these two is very important. How going from naming the specifics, I'm sorry, I have this wrong. Where's my eraser? Where's my eraser? Am I that blind today? Yes, I am. There we go. The link between, draw please, the link between these two. Sorry about that. So the first and the third are very similar. One time you want the specific senators, one time you want the number, and that changed a no to a yes. The link between these two, going from linking the specifics to just the number of them, it changed it from a no to a yes. So that's an important way that you can turn something that's not a function into something that is a function, but with less specific answers, kind of like that juice analogy we made earlier. How we got 9/11. Okay. So I have to clear my screen now so that I can go off of annotate. Please let me off of annotate, you silly program. Thank you. Let's go ahead and scroll down. So we did up to this one. So now we're here. 1, 2, 3, 4, 5, 6. We got 6 left. I'm gonna do the next 2, and then I'll let y'all do the next 4. So that'll be your work. So we'll do these 2. So these 4 right here will be in Canvas. So that's 4 opportunities. I would like a yes or no answer as well as an explanation if you can. I would really appreciate, and your fellow peers would appreciate, an explanation as to why you think it's yes or no. And like I said, it's not, if you get it wrong, that's okay. So when I said there's 4 opportunities, actually there's more than that, because maybe someone makes a wrong answer and another student comes in and says, well, I actually think it would be this. And then you can have a discussion. So I don't want to say there's just 4 opportunities, but there's at least 4. So US citizens to social security numbers. Now, again, this is something we're going to have to do often in this course. They're not super specific about the level of detail. So we're going to assume that there's no hocus pocus going on here, no illegal activities with social security numbers, if you will. So US citizens. So if I said Rodney Beckner, could you have just one answer for my social security number? And the answer is yes. Although, as a TCC employee who has had his social security number stolen, I thought we were going to get new ones at some point, but I think that was not true. So I could have had a second one, but I didn't. I think. At least that's what they made us think at first. Either way, that's the type of detail I'm saying we're going to ignore. We're going to keep things simple in terms of our approach when we're doing these guided worksheets, because very often just by thinking in terms of something like that, or the mafia, they can buy and sell social security numbers, whatever you want to do. We're ignoring things like that. So US citizens to social security numbers. Well, if you say Rodney, then I could tell you my social security number, which I won't do. If I said Jane, you could tell me Jane's social security number. Now, if I ask Jane again, it'll be the same. So yes, saying a person's name, you can always definitively give them one social security number, assuming that they are a legal US citizen. Again, details like that we assume. Social security numbers to US citizens. So if I said, let's say this was a social security number, which is not 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I said that number, and then, oh, okay, well, that's Bob Dole's social security number. So I can say Bob Dole here. Or if I said the social security number 987-65-4321. Oh, well, that's Jane Austen's US citizen social security number. So yes, again. Now, what that means is, because both of these are a yes, if you swap the inputs, these are 1-to-1. Whenever you can swap the inputs and outputs, it's a yes either way. That is your 1-to-1 function. Okay, so for the last 4, again, these are your homeworks that'll be in Canvas sometime today, and those will be due by, today's the 26th, let's say the 28th. So any Canvas group work is always due by midnight the next day. So that'll be due, again, 28th, 5/28, and it's by midnight. It's always by midnight unless I say otherwise. So people to birthdays and birthdays to people born on that day, then students to a shoe size, and then shoe size to students. Think very carefully about these 4. Just because it works one way doesn't mean it works the other way, because we saw in this one it did, but earlier when we did the states and senators and swapped them, it didn't. So I'm not telling you whether these work both ways or just one way, but I will say that each of these pairs works at least one way. We're not going to do number 3. Honestly, people always have a very difficult time with this one. So come up with a function between 2 quantities which remain a function when you switch the inputs and outputs. One of my favorite ones is the number of gallons of water to the weight of water. And it doesn't have to be water. It could be any fluid as long as it's the same fluid, because different fluids have different densities. That's a topic we'll talk about lightly in chapter 3 or 4, one of those 2. So if I say 1 gallon of water, the weight would be a predictable number. And it's what, 8 pounds. Sorry, I had to think about that for a second. I had 16 in my head, and I don't know why. I know it's 8. I know it's 8. So 1 gallon of water weighs 8 pounds. I almost verbally said it wrong there. 1 gallon of water is 8 pounds. If I said 2 gallons of water, it would be 16 pounds. If I said 2 gallons of water again, it's 16 pounds. If I say 2 gallons of water again, it's 16 pounds. Or I could say 16 pounds, and then you would know it's 2 gallons of water. Those are always a consistent ratio. It's a proportional relationship. The emphasis on those words is important there because we're going to talk about that stuff later. All right, next page. So I got to clear my screen. Go off of annotate. So then we have objective 2, exploring financial functions. Let me make sure I didn't have anything else I wanted to say here. I do. I don't put things in bold very often in the chapter notes to share. I put this in bold. There must be a reason for that. These right here, some people would call a series of formulas. I call them a series of concepts. So again, for me, a concept is one operation. A formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. That's a formula. These are concepts. So APR, that's annual periodic rate. Again, APR is annual periodic rate. So I don't think I wrote that anywhere up there. So if you wanted to find a non-annual rate, you just take the APR and divide it by the number of periods. So when you borrow money or when you put money away into a savings, you get interest or you pay interest, depends on which side of the argument you're on. But that interest we associate with an APR, an annual percentage rate. Why did I write periodic? I was looking at the word periodic, annual percent rate. Geez, sorry about that. Annual percent rate, annual percent rate. Periodic rate is the annual rate divided by the number of periods. So a period is how often that the interest accrues. Again, a period is how often an interest accrues. A lot of things accrue interest monthly. So that means after 1 month goes by, then the amount of money in the account gains, or the amount that you owe gains. Some things will gain annually, which means after a year, after a month, nothing happens. After 2 months, nothing happens. After 5 months, nothing happens. But after 12 months, boom, all of a sudden, all that interest for the whole year is added. So let's say that you had to pay 12% on a loan, 12% APR. So that means that if this loan was paid annually, 12 months would go by and then you'd pay 12%. Well, let's instead say it was a more normal situation and you were paying monthly interest. So your periodic rate, you would take the APR of 12% and divide it by the number of periods, which would be the number of months. Paying monthly means you pay every month. There's 12 months in a year. So there's a whole bunch of common ones that we'll see very briefly. So periodic rate is you take the annual rate and divide it by the number of periods. So if you want to pay daily, you divide by 365 or 360 in some instances. I'll explain that in a minute. Monthly interest. How do you calculate the monthly interest owed, depending on which side it is? Well, you take the balance of the loan or savings account and you multiply it by the periodic rate. Now, this says monthly interest. You could also just say periodic interest. In fact, I want to change that. It is typically monthly, but it's not always. 99% of the time in this class, it's a monthly interest, but I'm not going to guarantee it. The total number of payments that you have to make of something is the number of times you pay it per year times the loan term, which would be in years. So let's say you were making monthly payments for 2 years. That means you would pay this loan 24 times because you'd pay it 12 times the first year and 12 times the second year. Or just 2 times 12 is 24. If you paid a loan for 5 years, that's 5 years at 12 months per year. 5 times 12 is 60. If you paid a loan for 30 years, like a home mortgage typically, that's 30 years at 12 months per year. 12 times 30 is 360. So when you get a mortgage, you are generally making 360 monthly payments on a 30-year loan. So again, these are very basic concepts. How do you find the total of something? Well, it's the number per year times the number of years. How do you find the total paid? Well, it's the number of times you pay it times whatever you're paying each time. PMT stands for payment. I don't even feel the need to type that up. PMT is payment. So if you pay 10 bucks a month for a year, you'd end up paying 120 bucks. If you paid 10 bucks a month for 2 years, you'd end up paying 240 bucks, because 10 bucks times 24, or 10 bucks times 12 in the first example. Now, with this interest, that means that somebody's getting more money for being nice and letting someone else borrow it. So your total interest amount is the total paid minus the principal. Principal means what you borrowed, or initial investment. Again, depending on your perspective. So let's say you get a loan for $1,000, but after you pay $100 a month for 12 months, you end up paying 1,200 bucks. So your loan was for $1,000, but you ended up paying back 1,200. That means the interest would be 1,200 minus 1,000, which would be 200 bucks. And we're going to do some of these calculations non-verbally sooner than later. The percent towards principal. This is not a calculation we do a lot of in this course, but it is a nice one to know. You take the principal and you divide it by the total that you paid. This is just a basic ratio of principal to total. Again, we'll talk more about ratios later, but that's what this is. And then this says multiply it by 100%. Honestly, the last parts at the end just mean to convert to a percent, because they are percentages. APRs are percentages, APYs are percentages. A percent towards principal literally has percent in the name, as do APR and APY. So that times 100, what a lot of people generally just do is move the decimal twice to the right. So that's perfectly fine, and that's something you're supposed to already know. How to go from a decimal to a percent, move the decimal right twice. So APY, that's the total interest in 1 year divided by the original principal. APY stands for annual percent yield. APR and APY are close to each other usually, but not the same. Now, I put close in quotations because, well, sometimes they're really close to each other, and sometimes not so much. Sorry, I'm looking for something. Okay. So periodic rate, take the annual rate divided by the number of periods. Periodic interest, take the balance times the periodic rate. Total number of payments, that's the number of payments per year times the how long you borrow in years. The total paid is the payment, number of payments times the payment. Total interest is the difference of total paid and principal. These top 1, 2, 3, 4, 5, we will see over and over and over and over. And then we won't see them for a while, and then we'll see them over and over and over and over. If there's 5 things I want you to learn from this whole class that you'll remember 2, 3, 5 years from now, this is one of them. Don't ever forget this. There are some things that I'm going to teach you that I could whisper in class and say, it's okay if you forget this 2 years from now because Google is your friend. Not this, though. This is something you should know in your everyday life to make sure that someone is not messing you up financially. Very simple concepts. I'm looking at the worksheet and I'm just kind of questioning whether, yeah, this is fine. This is fine. Okay. I was kind of wondering if I needed to make up my own example worksheet. All right, so in that worksheet, here's some definitions. You could use this and go fill those out. We did all of those pretty much. We did do all of those. So right here, this is very important. Write this down if you aren't going to refer to your worksheets constantly. Another good thing about a good aspect of being a student is take good notes. Don't just look at stuff and skip writing. So these are some very common values for N, which is the number of periods per year. So if we talk about something being compounded monthly, and we don't use the word compound too often yet, but that's what we're really getting to ultimately. But if you are accruing interest monthly, there's 12 months in a year, so 12 is the number of times that you would accrue interest in the year. So your periodic rate would be whatever your annual rate is divided by 12. So they said, all right, let's assume we have a rate of 12%. I said that earlier when I was talking. So if you assume there's an APR of 12%, so this is like a really, really good credit card or a really, really bad student loan or an absolutely horrible mortgage. But I do know someone that has a 12 or 13% APR, and I feel pity for them. That sucks. Some of you might, and I feel the same pity for you. That's not fair. It shouldn't be that way, but we're not here to fix your interest rates. We're here to do the math behind them. And if you can refinance and get a better rate at some point, that's how you fix that. So if your annual rate is 12%, so you'd pay 12% over a year, that means monthly, you're taking that 12% and dividing it by 12 because 12 months in a year, which means you'd be paying 1% every month instead of 12% every year. Now, what you might think is, well, wouldn't those be the same? And it depends on whether your interest is compounding or not, which in the real world, interest always compounds. So we don't get into that math quite yet on the technical level, but we will show how Excel can help us with the concept at least. All right, so what if you compounded interest quarterly? Quarterly, quarter 4, there's 4 quarters in a dollar, there's 4 quarters in a year. Now, a lot of people say a quarter is every 3 months, but every 3 months means 4 times a year. There's a little bit of easy confusion in that scenario, unfortunately. A quarter says you're dividing by 4 because it happens every 3 months. So if you were paying 12% per year, that means when you divide it up quarterly, you're only paying 3% every quarter. So 3% for the first 3 months, then 3% for the next 3 months, 3% for the third 3, and then 3% for the fourth 3 months. If you were paying interest weekly, which is kind of rare, but it could be done, there's 52 weeks in a year, so you're dividing by 52. So you take your 12% divided by 52, and you get this, and they rounded to 3 decimal places. It's not really just 0.231. It's 0.23076923, blah, 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 blah. And then daily, there's 365 days in a year, ignoring leap year. So you take the APR and divide it by that. And you can see that the larger the N is, the smaller the periodic rate is. Now, what some people will think is, oh, okay, well, I want a smaller rate, so I want to be paying my interest daily instead of weekly or monthly or quarterly. But the thing is, it doesn't quite work that way. The periodic rate is very, very small, but now you're going to be paying this interest every single day. And if you stack that up at the end of a year, it adds up to a 12% APR. Or if you paid this 0.231 52 times in a year, then that 0.231 52 times makes your 12% annually. This is just written out as a fraction of something we had earlier. APY is the ratio of total interest in 1 year to the original principal. And you might think, well, why is that different than APR? The interest over 1 year, they're all adding up. this is not always the same because of a compounding effect that we're going to see very, very shortly. I'm going to do an Excel problem based on the guided work coming up. So we're going to see why the APY and the APR differ unless you're accruing interest annually. If you're accruing interest annually, they're the same, but that's the only time it ever happens, and we literally never do those problems. Okay, so guided activity 1 from this. Credit card loan, and this is a really weird credit card loan, and let's read the problem and see why that is. So let's assume you buy a Sony flat screen TV for your dorm room that costs $1,000. I have so many problems with this problem. If you're in a dorm room, if you have student loans, don't buy a $1,000 TV maybe, but that's an opinion. Also, I mean, flat screen TVs are a lot cheaper now than when they wrote this book about 3 years ago. So, you know, this is a really, 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 really nice TV at this point to be $1,000. So anyways, you make the purchase with a store credit card that has a 12% annual percent rate. You do not have to make any monthly payments for the first year, which sounds good, but they will still charge interest at the end of each month. How much do you owe at the end of the first year? So they charge interest monthly. So our interest is accruing monthly, but they say, you don't have to make the payment now, you can make it later. Now, in the real world, the way people usually do this is they have deferred interest. So they'll say first 12 months, same as cash. That's a common phrase, which means if you don't make any payments the first, second, third month, right now, you don't have any interest added to the account. And if you pay off this $1,000 TV loan, say in month 11 or month 12, then you only pay $1,000. But if you go into month 13, all the interest from the first year that's been calculated and sitting to the side will now actually go on your account. So that's how it usually works in the real world with like a deferred first year. There's a lot of credit cards that'll offer that, especially stores. Kind of feels like layaway almost, but with interest eventually. This problem is slightly different in that they're not saying we're not going to charge you the interest. We are charging you the interest. You just don't have to make the payment yet. This is kind of like the mortgage payments being deferred for a lot of people right now. You can not make a mortgage payment for like 3 months, but then guess what? You owe those 3 months along with the interest that was accrued in the 4th month. And that could have a negative impact on a lot of people, but let's not get into those semantics for now. Let's stick with the problem. So again, we're borrowing $1,000 basically at a 12% APR, but the interest is accruing monthly. Accruing, compounding, these are words that we'll get used to hearing and they will discuss in more depth later. So we're not actually going to make these payments. We're just going to see the interest accruing and they say, well, what is the principal? Principal is the amount borrowed or invested. That's the $1,000. So I'm going to write on the screen for a couple of minutes. This is our $1,000. What is the monthly or periodic interest rate? Now I have to answer all these to be able to do the Excel, so I can't give you any opportunities on this one. What is the monthly, aka periodic interest rate? Now remember, the periodic rate, it looks like I wrote pirate. The periodic rate is the annual rate divided by the number of periods. Just reminding us of that formula from earlier. Well, the APR was 12%. How many periods if we're accruing monthly? Well, there's 12 months in a year. So it's 1%. See the difference in my handwriting when I use this versus typing in Word? It's terrible. I don't know why. So we are accruing 1% of the balance of the loan every single month. Monthly interest is a function of what two inputs? Well, it's based on the APR or the periodic rate. You could say either of those things. It's based on the interest rate. So you could say the APR or the periodic rate. The periodic rate is based on the APR, so that's why it's equally an acceptable answer there. and how much you have remaining on the balance. And then what is the interest charge for the first month? So we're going to pay 1% of the balance for the first month. So we're going to take 1% of 1,000. Typically, percentages means you're taking that number and multiplying. And in those formulas, the bolded formulas from earlier, which I'd have to clear my screen to show you, so I can't, we said that the interest is the product of the periodic rate and the balance. Why did I write equals? It's what you owe times what you're paying in interest each period. So that would be the 1% times the $1,000. But if I'm going to show this in just normal math, I got to write 0.01. 1% is 0.01 times 1,000, which when you do that product, when you pull up a calculator, you'll get 10 bucks. So 10 bucks is what this store gets from us for being nice enough to let us take the TV off their hands without any money up front. Sounds really nice because they're not guaranteeing payment. They don't know that you're going to pay off this loan. So they say, hey, you should give us a fee for us giving you 4 figures worth of cash up front. So that's the interest for the first month. Now I need to scroll down, so all this is going to go away in just a second. Let's say 10 seconds just so you can absorb it. All right. Then we have this. They have an Excel spreadsheet built here. And what they want us to do is, in the above spreadsheet, we'll get into this stuff in just a minute. In the spreadsheet above, what formula is in cell C4? What formula is in cell D4? So what we want to do is set up an Excel spreadsheet, and I'm going to build this for us, where we're going to have the 12 months, the balance of the loan each month, the interest of the loan for each month, and then the new balance of the loan each month, along with all the little details set up to the side. So we have our principal of 1,000, that's what we borrowed, our APR, which is 12%, which we're paying monthly on, how many months there are in a year, which makes the periodic rate 1%. Then the interest is just the product of the balance and the periodic rate. Then the new balance would just be adding up the balance and the interest. So this $10, it took this $1,000 block and it multiplied by this 1% block. So we're going to use an Excel formula right here that will be the product of this cell and this cell. Then the new balance is just adding up the 1,000 and the $10. So this will be an Excel formula adding this cell and this cell. Then in month 2, you can go ahead and see the numbers. The balance needs to be linked to the old balance. This is a very, very, very common thing, linking an old to a new. We'll discuss this in just a minute. Then the interest, because the balance is just a little more, the interest is just a little more. Because that 10 bucks has now been added to our balance. We no longer owe 1,000, we owe 1,010. So the interest, because the balance is a little higher, the interest is a little higher. And then we add to get the new balance. And we keep going, we keep going, we keep going. But we don't have to fill that, we won't have to fill that out 12 times. We want to use Excel. And spoilers, we're going to need some of this fixed cell reference stuff. But let's do this wrong first, because that's one of the best things we can do with Excel to learn. Let's do it wrong. All right. So I'm going to set this up as quick as I can. And I would encourage you to replicate this. Oops. Because you will have a homework problem very, 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 very similar to this. Let's make things good widths. I'm not too worried about getting things the proper color. So a month, we want to have 1, 2, 3, 4, 5, all the way down to 12. Here's something cool you can do. I don't have to do that. Could have hit undo for that, but whatever. We can use the fill bar, which is when you have the cell active and you click the bottom right corner and you hold, to make all 12 of those months. Now, what I just did is not right. Let me show you what I did. I had a 1 here, and I want the next one to be a 2, then a 3, then a 4. So if I just have this highlighted, I have the cell active. If I grab the fill handle, click hold, and drag down, they just all say 1. Check this out, though. Let me have the cell active. You can't see me, but I am now going to hit the control button. I'm holding control. Now I'm going to drag it down, and look to the right of that. Look above the mouse. It's very, very small, but it says 3, then 4, then 5, then 6. Because I've got control down, that changes how the fill handle works. So now when I let go, instead of going 1, 1, 1, 1, 1, it goes 1 through 12, and I had to go down to the appropriate one. So again, what I did to make that happen, instead of just repeating the 1, is grab the fill handle, hit control. The order you do those two things doesn't matter. And then you can see that it makes it appropriate. Another option is I could have the 1 and the 2 done. I can highlight both of those, then grab the fill handle, and it knows that I'm going to want to increment the numbers because it went 1 and 2. It figures out there's a pattern to it. But with just the 1, it doesn't quite know the patterns there unless you hit control. There's subtle things with Excel like that. And again, there's little videos that tell you that, along with me telling you that. So to the side, the principal was supposed to be 1,000. The APR, that was 12%, not 12% Q, 12%. The period, that was monthly. Number of periods in a year was 12, which makes the periodic rate. And I'm not actually going to just type 1%. I'm going to take equals, so I'm using a formula. The annual rate says, hey, you mean this one? Then I hit slash for division. And the number of periods in the 12. So that's the 12% divided by 12, which we showed on, quote, paper earlier. And that says 0.01. Why is that? Because this is not formatted as a percent. I can format it as a percent, though, and boom, there we go, 1%. So that was right here. I can hit undo. If you prefer seeing it as 0.01, that's fine, but usually we like periodic rates as percentages. So our initial balance was $1,000. And you might say, well, link it to the principal. You can, it's not the best idea for this though. So $1,000, you can type the dollar symbol first, or you can format it after. The interest is supposed to be the product of this balance and the periodic rate. Let's use Excel to do that though, so that I don't have to type 10 here and then 10, 10 here, and then I would actually have to go and calculate all 12 of these. I don't want to do that math. I want Excel to do it for me. So let's clear that. So Excel, think for me, equals. Now remember, the interest, the periodic interest, is the product of the balance and the periodic rate. Here's your balance, here's your periodic rate. So I need to be multiplying these two cells. So take the 1,000 times the periodic rate where it says 1%. Now remember, you can type cell B4 times G6, or you can click and then times and then click. I'm a bigger fan of clicking. So blue and red, those are the things I want to multiply. Yep, looks good. New balance. The new balance is the sum of the balance and the interest. So this is just equals, and we'll be adding these two cells. So the balance plus the interest. And then when I hit enter, we get $1,010, which makes sense. Okay. Next up, we are supposed to link this to this, because our new balance at the end of the first month is the balance at the beginning of the second month. So this should be 1,010. Now, I don't want to type 1,010 here. This is not what I want to do, because then I'm going to have to type that every time. I don't want to do that. I want Excel to do all of that for me. So I'm going to write this down after the fact, but here's what you do. It's super simple. You type equals, and because I want this to be the same as this cell, just click that cell. That's how you link the new balance to an old balance, or an old balance to a new balance. You just say equals that cell. So whatever is in this cell right here is going to be displayed in this cell also. Whatever is in this cell will also be displayed in that cell. If you don't believe me, let me just overwrite this and write 17. So if I write 17 here, look what happens. They're linked, so that one updates. But I certainly don't want that. So again, how did I do that? I need the balance at the start of month 2 to be the same as the end of month 1. So I go equals, and then I click the end of month 1. So that's how we link new to olds. This is very, very, very common with finance spreadsheets. Now, this interest formula, the B4 times G4, B4 times G6, if you double click it, it'll pull up boxes. So that was supposed to multiply the blue and the red, and those are the correct. So the box below it, we're supposed to be multiplying the 1,010 and the 1%. And I could just type it out. Let me hit enter. I could certainly type this as equals and then click here, then times, and click here. And we get the 1010, which we've already seen. So that makes sense. But I don't want to have to type the formula 12 times. I only wanted to type it once. So here's what you're supposed to do. You're supposed to use your fill handle for both of these columns. And we will use the fill handle in the first column now later, but let's pause on that. So if I make this cell active right here, where the $10 is, where we had that one and that one. So if I make this active, if I grab the fill handle and I drag it down, what you would think is that you should have 1,010. And you would think that it's going to multiply the 1,010 times the 1%, and it would give us our $10.10. That doesn't make sense. Why is our interest $0? So if you have a number that makes sense, double click the cell and see where the colors are. So what it's multiplying is the blue and the red box. Does the blue box look like it's in the right spot? And then this is where the class goes, yes. Does the red box look like it's in the right spot? And this is where the class goes, no. So there's a problem. What exactly has happened here? Remember, the fill handle always makes the initial assumption that you want your rows to go down or your columns to go right, whichever way you're moving it. So if I filled this thing down all the way, if I then say click here, it's multiplying the blue box, which would be correct. The number here is what we want to multiply, but then it's multiplying by this one because this box just keeps going down as well, but we don't want it to. This 1% is only here. We need the red box to be right here each time. So we want the blue box moving down, but we don't want the red box moving down. This is when we need fixed cell references. A fixed cell reference makes it so that one of these does not move. Now, maybe you don't want anything moving. Maybe you want some of them moving. Maybe you want all of them moving. So you have to practice and you have to pay attention. So let's get rid of this stuff. I don't know why that didn't work. There we go. And let's go back to our notes to share. These are the same things that you'll see on the guided worksheet. But the point is, to use fixed cell references, you need a cash symbol somewhere, the dollar symbol somewhere. Sometimes in the front of a letter, sometimes in front of the number, sometimes in front of both. So we have to understand what does what. So when you just say A4 or B7 or C9 or D2, oh no, I think Word's about to crash. This might be a problem, but let's just see how long it lasts. So when you want to have everything always move down or always move right, you just use the standard cell references like we have been. So these were standard cell references, B4 times G6. But we don't want that red box moving, so we're going to need to put a cash symbol somewhere on it. So let's see. If you put a cash symbol in front of the letter, that will fix, and what I mean by fix is it wasn't broken and you're fixing it. I mean it keeps it rigid. It makes it stay in place. It fixes the column, so filling a formula left or right will not change the letter. So that, in other words, makes it not move left or right. The cell reference, that is. So putting a dollar symbol in front of the letter makes the letter not change. So the dollar symbol says, hey, this thing shouldn't change. If you instead put the dollar symbol in front of the number, that says, hey, the row number shouldn't change. The row is actually a height. I know it seems contradictory. So that fixes the row, so filling a formula up or down will not change the number. In other words, it makes it not move up or down or up. That's the important aspect. So when you don't want a cell moving up or down, you need to put a cash in front of the number. When you don't want a cell moving left or right, you need to put a cash in front of the letter. Sometimes you don't want it moving at all, so you'll need to fix both of them. So that makes that specific cell reference never, ever, ever change. It won't move left, it won't move right, it won't move up, it won't move down. It stays the same, it stays fixed. So all that is pretty much exactly what you see in the guided worksheets right here. So they just call that last one an absolute cell reference. That's the only thing they have in addition to what my notes say. But I also have a nice little summary in bold. When filling a formula to different rows and columns, any data from a column must have the column fixed. Any data from a row must have the row fixed. We're going to talk about that sooner than later, but your, I think third Excel homework, either your second or third, this is going to be an issue. I want to say second, actually. This is going to be a pretty common issue in about half the homeworks, maybe a third of the homeworks. But let's not throw too much at you all at once. So let's just practice with this stuff. Just practice with the fixed cell references. Okay, so we knew this was wrong. The blue needed to move down. We did want that blue moving, so we don't need the blue reference moving down, but the red one we did not want moving. So and you gotta type the cash symbols after the fact if you're clicking. So let me just goof this up a little bit. And you got to go back to the first formula. The very first one is where you need to actually put the cell references in. So if I have that B4 times G6, dragging it down, that was wrong. So undo. So I need to go back to this, and I need to put some cash symbols in. Now the blue one, we said we want moving down each time. Let me show you what happens if you do this wrong, though. Maybe you put a cash symbol in front of the number for the blue reference. So I cache the 4, which means this blue box will never move down. Now this box is still correct. If you double click it, blue's good, red's good. But if I drag this down, now the blue is in the incorrect spot as well as the red is in the incorrect spot. The red moved down even though we didn't want it. The blue did not move down even though we did want it. So we're not supposed to be caching the number for that reference. Okay, well maybe we want the B cached. Maybe we wanted that cached instead. So let me clear it. Remember, I only want to actually edit this one. So let's do this. If I then fill that one down, well, the blue box moved fine. The red box is still a problem because we haven't manipulated that one yet. Honestly, though, this isn't good. It's okay for this problem, but if you had that a table of information like I mentioned before, which we'll get to later, this would be a problem potentially. You might not want that there. You might not, it depends, but honestly, it's not necessary for this. So that is not what I was supposed to do. So let's undo. So again, because the blue box is perfectly fine moving down every time, we don't need to do anything to the blue stuff. But the red one, we need this one not moving down. So I'm gonna do it one way. Maybe this is right, maybe this is wrong. So I put the cache in front of the letter, which means the letter won't change. Letters are left and right though. So if I was trying to move this left or right, now it won't. So let me hit enter. but I'm dragging it up and down. And look at that, it's still not right. It still went down. So clearly I put the cash symbol in the wrong place. I'm not just telling myself right now how to do this. This is the stuff you should be doing in your homework. When you get an answer that doesn't make sense, go back to what you did. First of all, see if your cell references are right. Maybe they're not. Second of all, maybe you needed to fix cell references and you put the cash in the wrong spot. Do things wrong to learn how to do them right. Again, your teacher, all of your teachers, anyone who's ever learned Excel has done this stuff wrong 10 million times. And then they cried on their desk, and then they went back and they did it right. Sitting and staring at the screen doing nothing will earn you nothing. It will earn you no knowledge. It will earn you no points. Try things out. Please and thank you. Okay, so that was wrong. Let's undo it. Go back to the OG, the original. All right, the cash in front of the letter didn't work. So maybe I should put it in front of the number. Let's try that. Drag. And lo and behold, we have the right formula, but something looks weird because when I hit enter, it just says $10. Was it right? Yeah, 10 times 1%. That is right, but why is it only showing $10? Well, maybe, just maybe, the decimal precision needs to be changed. And it's odd because my work computer normally does it automatically. This one is not. So let me just highlight this whole column of interests and new balance numbers. And let's just go ahead and make the decimal precision money. There we go. See, because I typed the dollar symbol, it didn't assume I wanted decimal precision. But if I actually hit the dollar symbol, it knows it's in an accounting format. Now all those are correct. Now maybe the same thing is going to be true of these over here. So let's make sure those are in an accounting format. Now the new balance is supposed to be just adding these. Maybe I can just drag this one. So blue and red adding, that looks good. Make it active. Grab the fill handle, drag it down. That looks good. If you don't trust it, double click the cell to see the colors, and we're supposed to be adding the blue and red. So that's excellent. I didn't need fixed cell references for this one because both of the values I wanted to add had values here. They're moving down, and there'll be values here. There'll be values here. It's whenever you're using the periodic rate that's only written once, you don't want that one moving, which is why it needs to be fixed. Typically, it's stuff to the side that needs to be fixed in a reference, or when you have a table of information, like a multiplication table we'll introduce later, those need to be fixed. Now, okay, we're supposed to have the balance be the new balance and the old balance match. So you go equals and click. You don't actually have to because we had a formula here. The very first one wasn't a formula. The second one was. So because that was linked there, if I drag that down, the blue box will drag down. And look at that. It's linking the old and the new. The old, or the end of month 2 to the new, the end of month 2 to the beginning of month 3. Now, if I take the interest formula and drag it down 1, boom, it went up a little. That makes sense. The new balance goes up a little. Let's double click and check. Yep, we should be multiplying that blue by that red. Enter. Double click. Yep, we should be adding those two things. Now, once you have a completed row of formulas, you can just go ahead and go all the way down to month 12, and you can do it as one column like this, and it'll look ugly until you finish the rest. Make active, fill, make active, fill. Oh, that wasn't a fill. What happened? I did that wrong intentionally because I grabbed the border instead of the fill handle. Undo, grab the fill handle, and fill. And there are our 12 months of balances, interests, and new balances without having to do this month by month. So now maybe this was a 5-year loan. We could do this for all 60 in the snap of a finger now. If this was a mortgage, a 30-year loan, again, snap of a finger and it's done. So check this out. As long as you have one complete row, all with formulas, you can highlight them. So again, highlight. Highlight means just click and drag. Then grab the fill handle and drag that down to month 12, and it'll do all of them at once. Same exact numbers that we saw before. I'm telling you, this is an amazing tool. This is an amazing tool. If you don't trust any of these, does that look good? Yep. Blue, red. That looks good. Now, we only had to fix the row. We only had to put a cash in front of the number for this to actually work. But check this out. If I go back and I put a cash symbol in front of the G and the 6, let me clear out these with delete. So now with this slightly different formula, with the cash in front of the G and the 6, let's see if that has an effect on just filling all these down. Why didn't that work? I think I must not have grabbed it properly. There we go. Those are the same values as before. And if you double click month 8, this blue times that red. That's good. So there's actually two ways you can fix the reference here. We can put the cash in front of the G and the 6 or just the 6. Now the reason for this is putting a cash symbol in front of the G makes it so the reference never moves left or right. But our references are only going down, they're never moving left or right. So that cash symbol in front of the G is completely arbitrary. It is fine to be there, but it also works without it. It's good either way. So your guided worksheets, there are some questions that you can answer. In the spreadsheet above, what formula is in cell C4? What formula is in cell D4? There's a couple answers for number 5, so we're going to do these in our Canvas. So do these in Canvas. As I said, I'll have something set up no later than 1:30 today, but hopefully by 11, it's going to be a fight to get that done. I'm not going to say by 11, actually. I'm going to say it's going to be by 1:30. So in addition to those first 4, so I'll have it in the same section, but different questions. In the spreadsheet above, what formula is in cell C4? So C4, I'll do, well, that was weird. It actually let me write on my paper. With my paper over my, you know what, don't worry about it. It doesn't matter to you. So in cell C4, that was B4 times, and you could have the cash in front of the G or not. Now, if you wrote this, I'm going to go ahead and spoil something. This is wrong. This is wrong because it should have an equals in front of it. So I've done C4 for you. You need to do D4. So I did C4. Someone needs to do this one. That was when we were adding the cells. So again, this cash symbol, this one was technically optional. Which formula involves an absolute cell reference? So with this question, you could write C4 or D4. Only one of them does. So one of them we had to put the cash symbols in. Basically, the answer staring you in the face there. So this is you'll answer 5, part 2, part for D4, if you want to call it that. So we got to do this one. Then we're going to do 6. Why do we need to fill in the second row before we fill the formula down? This was when we were linking cells. I want someone to answer that, but the answer is linking old and new. What do you owe at the end of the first year? What do you owe at the end of the first year? I'm thinking for a second if I want to give you this answer or not. You know what? There's 4 of them there. 1, 2, 3. No, that's 3. Okay. I don't want to give you that one. And it's going to be a little ugly. But at the end of the first year, here's your beginning balance, then you add a little more interest, and then here's your ending balance. So you can see the number on the screen right now. Thankfully, there's nothing written on it. So there's what you owe at the end of the first year. Okay. What is the APY? So we're also going to do this one. Remember, APY, we said was a ratio of a couple of things. APY was your total interest for 1 year divided by the original principal. Now the principal was $1,000. That's what we borrowed. The interest over 1 year, well, we borrowed 1,000 and then we end up having to pay this much back. Remember, interest is the difference of what you owe and what you borrow. So you'll take this number right here, which I'm not saying out loud because it was one of the answers that I need you to give me later. You will subtract the balance and you're going to get $100 and some dollars. And that $100 some dollars is what goes here in that APY formula. So I'm going to say this is the answer to number 8 minus 1,000. Let me delete the cash symbol just because that makes it look ugly. Eraser. Draw. So it's the answer to number 8 minus the $1,000. And then convert it to a percent. I will tell you it's 12 point something, something, something percent. I want 3 decimal precision there. So 12 point something, something, something percent. So the APR was 12%, but the APY is going to be like 12.5 or 12.75 or 12.839, something like that. It will be less than 13, but it will be more than 12. And that goes with the idea I mentioned earlier that APY is bigger than APR. APY is like an effective yield because of what we call compounding interest. Because if you don't pay down this loan, you borrowed 1,000, but then the second month you owe 1,010, and the third month you owe 1,020 and 10 cents, and the third month you owe more and more and more. So because your balance keeps increasing, the amount that you pay in interest dollar-wise keeps increasing, so that 12% ends up feeling like you pay more. And when you get a credit card, you'll see an APR and an APY, and they're a little off. When you get a mortgage or a car loan or a student loan, the APR and the APY are a little off because they'll have it, all right, if you actually paid annual interest, it would be this 12% number, but because you pay it monthly, it ends up being a little higher. Now you might say, oh, it's bad to pay it monthly. Trust me, letting a year's worth of interest accrue before you pay anything down, that's actually worse. It is definitely worse to do it that way. Okay. So we have 4 more opportunities there, and I need to write these down somewhere so I don't forget. It was 5 for D4 and then 6 through 9. Okay. So I got to clear my screen so that I can scroll. Guided activity 2, we got right here. And this is just asking us for a couple different basic math practice problems. I'm going to suggest that you do the rest of these, but I'll do the first one together. I'm not going to make it actual group work in a discussion board. And remember that these are going to be in discussion boards in Canvas. So it's not in the main section where you find all the links and files. You have to click that tab to the left that says discussion boards. So I still have to set that up. All right, so for each of the following situations, determine the periodic rate to 4 decimal places of accuracy, and then the amount of interest charged in the first period, Creating a spreadsheet to do this will greatly speed up your work, but we don't have to do that because we're only worried about the first week or first month or first year or whatever. So a balance of $576 with an APR of 8%, and we're going to pay the interest weekly here. So the weekly rate, this is where we take the annual rate of 8% and we divide it by the number of weeks in a year, which is 52. And if you do 8% divided by 52, I can't pull up a calculator, but I trust that you can do that. You'll get 0.1538%. So that's our weekly rate. You're paying 8% over a year if you paid it all at once, but we're actually going to pay every week, so we pay 0.1538% every week. Then our first week's interest, this is the product of the rate and the balance. So we take the 0.1538 and we will multiply it by the balance of $576. So 0.1538 times 576, and you get 88. I did something wrong. 576 times 0.001538. There we go, 88. So this is originally 0.885888, but we're talking money, so we're going to round this to the nearest cent. So $0.88. Now that 0.1538%, that's why I messed that up, because I forgot to write the percent symbol. That is really 0.001538 times 576. If you're doing these calculations by hand, you have to convert the percents to decimals. If you're actually using Excel, which is what they kind of suggested, then Excel can handle percents. You don't have to convert them up front. But either way, you should get 88 cents when rounded to the, I'm sorry, 89 cents. 89, what am I doing? 89. 0.885 rounds up to 89. That's my bad. So that's the first one. There are 4 more. I have to clear the screen, but that's all you're doing. You're taking the percentage and you're dividing it by the number of weeks or months or days or whatever. And then for part B, you're taking that percentage as a decimal and multiplying it by the balance. So it's clear. Take off annotate. So for 2, you'll take the 3.5%, you'll divide it by 365. And then to get the interest, you'll take the 0.0, whatever that is with 2 extra zeros in front of it, excuse me, multiply by the 1396. For 3, you're dividing by 12 and then taking that number, convert it to a decimal, multiplying it by the 18,000. Same thing, same thing. And the last 3 are monthly because monthly is more common than anything else in the real world. Except with retirement plans are done daily because they change every day. Okay, so what I want to mention next is in the guided worksheets, you will see a ton of these Excel previews. Now, your first Excel homework that I'm gonna, excuse me for stretching and yawning. Your first Excel homework is going to be this one, and I'll type that up in the Word file at the end of class very shortly. But 1.1 heart rate is going to be the first Excel assignment that you have to do, and that will be due in a week, which is June something, June 2nd. So again, all that information will be typed soon. Every single Excel assignment I give you has a preview guided worksheet. Now, we don't do these in class. This is just something that you can do in addition if you feel like you need more help. Now, this Excel assignment is very, very, very short. There's only like 3 things you have to type, but you have to use fill, the fill handle. You have to make a chart. You have to put the chart where they say to do it. You have to follow the instructions explicitly, or you'll lose points. So these questions just kind of guide you along the way. Hey, in this cell, what formula should you type? According to this formula, heart rate is a function of what input? What are the units? How do you make this chart appear? So check this out. You're supposed to make a chart. They literally show you what the chart should look like. So if you get something that looks drastically different, maybe 2 sets of bars, because that's a very common mistake that people make, emphasis, emphasis, emphasis. So if you don't end up with this chart, you instantly know you've done it wrong. You messed up something. Maybe go back and follow the instructions more carefully. So again, I won't ever do these Excel previews, but they're here, and very often they'll show you parts of the answers which would help you. Hey, 1.3 TV loan, this will be the second one we do. This looks extremely similar to what we just did, except now, instead of just talking about balance, interest, and new balance, now we're actually going to make a payment each month so that we don't just have this thing spiraling out of control. So this is already pre-built for you. This is already pre-built for you, plus what the sections it doesn't say. And then there's some reflection questions that you can answer. This is not part of, remember, like I said, if you have to, I'll make it an assignment in a discussion board. This one right here, should you get a credit card and establish a solid credit history, do you know what a credit score is? So these are just some basic credit card questions. Yes, you should get a credit card and establish solid credit history. Credit score tells you how good or bad your credit score is. If you've never had any type of loan, you have no credit score. These are things that we talk more about at the end of the semester though. To pay off a credit card loan, it is smart to make the smallest monthly payment allowed, and why? That doesn't really make sense to me. To pay off a credit card loan, it is smart to make the smallest monthly payment allowed, and why? That is wrong. Not all of these questions are meant to lead you down the right path. A lot of people do the minimum payment trap, and we'll get into that at the end of the semester. Okay. So. It's gonna make me sign in. Oh, that was the e-text. So let's show you what your TV loan looks like. Assignments. Which, by the way, I deleted the stuff that shouldn't have been up there at first. So here's your, I think I said TV loan heart rate. That's the first one we'll do. Download it. Download it. You can't see it because the window's a little off, but there it was. The instructions are in a separate Word file if you want, but they're also in the Excel file. So here's your instructions. Only 5 steps. Very, very short assignment. In this cell, do this. In this cell, do that. In this cell, insert a clustered column chart, blah, 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 blah. Click recommended charts. If you don't do that, things are going to go wrong. So what does the actual work look like? So you're going to type something here, then you're going to type something here, then you're going to fill it down, then you're going to create a chart using recommended charts under insert. You're going to place that chart over here in these squares and only these squares. If you don't put it in these squares, things are going to be marked wrong. And you might get it wrong the first time. You got 5 attempts there, remember? And that's it. That's the whole assignment. And you already know what this chart should look like if you're paying attention because it was under the guided worksheets. That's the whole first assignment that is due in a week. When you're done, you choose your file to upload, and then you submit for grading. Remember, when you submit for grading, there are things you can click to get a detailed analysis of why you did something wrong. You might not understand something it says, but at least you know it's wrong. Sometimes it's better to explaining things, especially when there's charts involved. I feel like people have a hard time understanding how to fix it. The 2 biggest issues are generally you didn't put the chart where they wanted it, and you didn't use recommended charts when they told you to use a recommended chart. That's usually the issue. All right, so so Excel, heart rate 1.1, is due, what was that, June 3rd or June 2nd? I gotta check again. June 2nd by, what just happened? Undo, 11:59 p.m. You get 5 attempts. I only use the auto grader. I'm not going to go back and edit individual grades. It is extremely time consuming. There's a reason we have those auto graders in place. The first semester we had this course, they weren't there. And I think I just spent my whole life grading Excel files. It was a challenge. Okay, we also just completed 1.1, so at least my math lab 1.1 is due in a week by 11. Why does it keep doing that? Okay. And we have all of 7 minutes left of class, so I'm going to go ahead and call it a day there. So that means that you need to read 1.2 text and notes to share before next class. There's some order of operations stuff. I'm also going to suggest and 1.3. We will definitely finish 1.2 and 1.3 next time. If you are confused as to what the chapter 0 spreadsheet is, you need to go back and watch the lecture from last class because that's where it is. I'm not going to spend 5 minutes detailing it. So go back and watch the lecture that's linked in YouTube. And again, if I don't have that submission up already, which I think I do, I will have it up in Canvas. So you normally will not submit Excel assignments in Canvas. This is an exception because this was something that we built in class together based on the Chapter 0 guided worksheet. So the spreadsheets that were built in Chapter 0 guided worksheets, that's what you're submitting. And you can literally just copy everything I did from the video. Again, the thing that I did in video is exactly what you should be submitting. I am not going to be grading these extremely rigorously. This is more of an effort grade right here. This is an effort to make sure, hey, you're practicing this stuff. So again, if you missed last lecture, there are no excuses for missing lectures in this course ever because they are all digital. Alrighty, so that's it for the day. No problem there. Remember chapter 0 spreadsheet. Again, this is just the odd man. It feels more like a project, but it's not counting as a project because I did the whole thing for you. That will be due in Canvas. The Excel heart rate, that is submitted in my math lab. The my math lab homework is also just submitted in my math lab. Each time you do a problem, it's submitted. And remember, keep practicing. Read the next 2 sections of text and notes to share. We'll knock those out of the park next class. I'll have those discussion boards set up by 1:30. Remember, discussion boards are due by the 28th. If you do not do a discussion board discussion this time, that is okay. It could be because everybody answered them all already, or maybe you just didn't do it. I'm not saying you have to participate in every single one. I'm saying you need to participate in as many as possible. You know, I would say 2 out of 3 is a pretty good basis. 2 out of 3 to 3 out of 4. That's what I'm going to be looking for by the end of the semester. I can't give you a concrete number yet, but I will at some point. So on that note, have a good one. We'll see you on the internet on Thursday. I'll have this video uploaded no later than 1:30. I'll try and get it before my next class, but it just depends on how quickly it works. It takes a very long time to convert 2 hours worth of video, believe it or not, and I have to convert it twice. So have a good one. Email me if you have any questions. You can ask questions on Canvas as well. And yeah, take it easy, get to work, and have a good day.